Hello guys, this is Jitenjan and I'm here to discuss few problems of GATE 2017 EC batch morning session. Okay, so from that session our first problem is the from the digital electronics. The first problem is the clock frequency of an 8085 microprocessor is 5 megahertz if the time required to execute an instruction is 1.4 microsecond. Then the number of T states needed for executing the instruction is, options are given, 1, 6, 7, 8 seconds. So clock frequency is given 5 megahertz and the time required for that instruction is given. We need to find number of T states for that instruction. So if we find okay, so from that clock frequency we can find time required for one T states. Okay, so so let uh, the instruction require t states. So x t x time t t state time is equal to 1.4 microsecond. Okay, so micro is 10 power minus 6 second. So how to find the time for one t state? So it is 1 by f. Okay, clock frequency, 1 by clock frequency is equal to 1.4 into 10 power minus 6, and f clock frequency means clock frequency is given 5 megahertz. So it is like this. So x is equal to, we can multiply this, so it will come 7 second, 7 t state. So answer is C. Okay, so our next problem is consider a single input single output discrete time system. Okay, with xn as input and yn as output, where yn and input and output are related as yn is equal to nxn for n 0 to 10 and otherwise xn minus 1. Which one of the following statements is true about the system? So four options are given, like causality and stability. Uh, we have to make a decision about causality and stability of this system. So for causality, uh, the system will be causal or not. We know that system will be causal if the output depends only on the present input or present or past values of input. Okay, so the output should not depend on the future value of input. So here you see for n values from 0 to 10, so yn is equal to nxn. So if you, so here clearly mentioned that present output depends only on present input for this range of n, and for other range of n, other values of n, the output depends on the present input and past input, present value and past value of inputs. So it is definitely causal. System will be stable or not? So for stability, uh, if we provide bounded input, so we should get output also as bounded, so that we can say that system is stable. So if system is stable, then if we provide bounded input, like step function is bounded input, we can't apply the ramp function is unbounded input, so we can apply impulse, we can apply step function is simplest function, which is bounded. So un, if we provide un, so here you can say n varies from 0 to 10 only, so n doesn't go to infinity. Okay, so yn is finite, xn is un, which is bounded, output is also bounded for this range. And for other range, suppose un, we apply un, so un minus 1, it will also be bounded, so it will be stable, because un is 1 for n greater equal to 0 and un minus 1 will be 1 for n greater equal to 1. So for n greater equal to 1, this value will be 0, and for n equal to 0, it will be 1. So which will be bounded? So our next problem is, so its answer is causal and stable, which is option is A. Okay, option is right answer is A. So next problem is from maths. So consider the 5 cross 5 matrix. Here it is given. It is given that A has only one real eigenvalue. So and others are, so here it will contain 5 eigenvalues. So other 4s are imaginary. So then the real eigenvalue of A, we need to find real eigenvalue of A, and it contains only one real eigenvalue. So 4 options are given. So how you will solve? Uh, we know that mod of A minus lambda I is equal to 0. Yeah. For, so so what, so the matrix will become 1 minus lambda I. This is mod, means determinant. So 1 minus lambda I, 2 3 4 5. Similarly here 5 4 3 2, 1 minus, so it will be 1. So 1 minus lambda, 1 minus lambda, 1 minus lambda, 1 minus lambda. This will be 5 4 3. This will be 2 1, sorry 5 4. This will be 5 2 3 4 3 2. Okay, so this will equal to 0. So now we need to find real eigenvalue. Okay, so we can apply a row operation like r1 on r1 plus r2 plus r3 plus r4 plus r5. Okay, so what it will become? So 5 4 9 9 3 12 12 to 14 1 15. So 15 minus lambda. Below will be some same value, so I won't write that. So here also you will get 15 minus lambda, 15 minus lambda, 15 minus lambda, 15 minus lambda. Now you can take common from first row, 15 minus lambda, and other determinant will be same. There will be 1 1 1 1. So it will be 15 minus lambda equal to 0. 15 minus lambda equal to 0. So lambda is equal to 15. So real eigenvalue will be 15. So option C is correct. So next problem is the rank of the matrix M. So rank we need to find. So best method to find rank, the get this matrix into echelon form. For higher order it will be helpful. Here only order is 3, so you can do directly that. Get try to get determinant of this matrix. If it is non-zero, the rank will be 3. But here you check for once 5 1 3 10 0 6 10 2 6. So you try to find determinant of this. So what you will get it. Okay, you take 3 common here, 3, so 1. Okay, keep it here. So 5 into minus 12 minus 10 into 6 minus 6 0 plus 10 into 6. So it will be 0. Okay, so it will be 0. So the rank is not 3, it is confirmed. Now you try to get submatrix of order 2. Suppose let 5 1 10 0. So the determinant is minus 10, which is non-zero, so rank is 2. So option C is correct. So it was easier problems, but you may get a higher rank matrix. So for that you try to get echelon form of that matrix, and then number of non-zero rows in that echelon form matrix will be your rank. Okay, so next problem is from analog. So for the analog electronics, for the op-amp circuit shown, the output saturation voltages are plus minus 15 volt. The upper lower threshold voltages for the circuits are respectively. 4 options are given. So you need to find the op-amp is in positive feedback. So positive feedback means definitely output will be saturated. Okay, so you need to find the upper and lower threshold values of the input. Okay, so that output will get switch from one state to other, so plus 15 volt to minus 15. So let at initially the here the voltage at positive terminal is 0. So V in will be some positive value. So V in, so 0 minus some be positive will be negative. So the output will be minus 15 volt. Okay, so make a different circuit minus 15 volt, 10 k ohm, so 5 k ohm. Here current will be 0. Okay, base current always 0, whether it is positive or negative feedback. Okay, so what will be the here value of voltage here? So let it is V. So the current will be minus 15. Apply node here. Better to apply node KCL here. So V plus 15 by 10k plus V minus 3 by 5k is equal to 0. So plus 15 2v minus 6 is equal to 0. So 3v minus 6 9, this is minus 9, v is equal to minus 3 volt. So v is equal to minus 3 volt. So it will be lower threshold voltage or upper threshold. You need to be careful at this point. You so for some positive value of V in, output is minus V set. Okay, minus 15 volt. So to get switch this output into plus 15 volt, you need to take V in below this value. Okay, so below this value means this is lower threshold value. You need, when the V in will become less than this point, then only it will be saturated at plus 15 volt, it will be switched. So this is lower threshold value, because if Vin is increasing, the output we won't get switch. Only when the input gets below than this value, minus 3 volt, so lower threshold value, then only. So lower threshold value will be minus 3 volt. So whether option will be B or D will be right. So we need to get upper threshold value. For upper threshold value means if goes below this value here, so if Vin goes below this value, minus 3 volt, so output will be, because minus 3 and some more negative number, so the difference will be positive, so output will be plus 15 volt. So let me make a different circuit, plus 15 volt and 10k, same V, 5k and 3 volt. Okay, so apply KVL here, KCL, sorry. V minus 15 by 10 plus V minus 3 by 5 is equal to 0. So 3V 6 and here 15. So 15 6 21. So V is equal to 7 volt. So okay, sorry, minus 20, minus 7 volt. Okay, no, here minus, so here will be plus. Yes, plus 7 volt. So option B is correct. Okay, so if you have any doubt, you can comment me in the comment section so that I can clarify the doubt. So in the circuit shown, the positive angular and this is from network. So the positive angular frequency omega in radian per second, at which magnitude of the phase difference between the voltages V1 and V2 equals pi by 4 radian is, we need to find the omega's value. For that, the phase difference between voltages V1 and V2 is pi by 4. Okay, so answer I have written here, 1.9 to 1.1 range. So okay, how you will proceed? First you try to get this is from phasor domain, so you need to find you need to make a phasor diagram circuit for this. So this is here degree phase is, so for the source. Okay, so you make a source of 0 degree phase and amplitude 100 and 1 ohm. So here will be the impedance will be okay 1 plus omega, and here will be 1 ohm. Okay, so V1 and here V2. Okay, so okay 1 plus omega, you can write as under root okay 1 plus omega is right. So what will be the V2? V2 will be V2 will be 100 at the angle 0 degree divided by 2 plus omega into 1 plus omega. Yeah, so you make you write into phasor domain. So 100 divided by under root 2 plus 4 plus omega square. So tan inverse angle at tan inverse omega plus tan inverse, sorry, minus tan inverse omega by 2. Okay, so V1 will be same 100 divided by 2 plus omega at the angle 0 degree into 1. So 100 divided by under 4 plus omega square angle minus tan inverse omega by 2. So we it is given in question that phase difference between V1 and V2 is pi by 4. Magnitude of phase difference. Okay, magnitude of phase difference between V1 and V2 is pi by 4. So V1's phase is this and V2's phase is this. So if you subtract these two, you will get cancelled this term and this term. You will get only tan inverse omega. So tan inverse omega is equal to pi by 4. So omega is equal to 10 pi by 4, which is 1 radian per second. So answer is 1. Okay, so next problem is a good transconductance amplifier should have. So for that you need you need to clarify that for transconductance the gain is like I by V. Okay, so output is current source and input is voltage source. So it is voltage controlled current source. So at input you are applying some input voltage. Okay, V in. So we know that for a voltage source the input resistance should be high. Yes, should be high, so that whole input will be transferred here. And for the current source, for the current source the the whole the current source the resistance becomes in parallel. Okay, so output resistance become in parallel to current source, so that the whole current, so R0 should be very less, so that whole current passes through the load. Okay, so for the current source, the output load should output resistance should be very less. So and for input voltage the Rin should be very high. So high Rin, sorry, R0 should also be very high, so that whole current passes through RL. Okay, so Rin should also high and R0 should also be very high. So option C is correct. Okay, suppose VCVS, we have voltage control voltage source, then input is Vn, output is also voltage source, and we know that voltage source has the resistance in series. For then that at that point the output voltage source should have very less resistance, so that drop will become very less. So you need to take care, you need to be very careful for this. Okay, so I will try to solve few other problems in next lecture. Okay, okay, then thank you.